Welcome back, grade 9s. This is lesson 2 on chemical reactions, and we're going to go through some basic principles. First of all, we must know that matter is conserved during a chemical change. It means that you cannot destroy atoms of the elements. You can change the composition of a substance, like the example of magnesium reacting with the oxygen to make magnesium oxide, but you can't destroy magnesium atoms and you can't create magnesium atoms. The same applies to oxygen. So matter cannot be created or destroyed. It can change from one form into another form. This is a very important principle. The second thing is the law of conservation of mass. So during a chemical change, we have reactants on the left-hand side of the arrow. That will be the stuff reacting or undergoing a change. And on the right-hand side of the arrow, you will have the products. Now, the total mass of the products will be the same as the total mass of the reactants. And Lavoisier was the person to say this. So let's look at our example. I'm going to go through the basics right down from the models to the symbols and balancing the equation and then calculating the mass of the reactants and the mass of the products. So the word equation is magnesium reacting with oxygen to make magnesium oxide. Now, to use models or diagrams, or like I call them ball diagrams, we need to refer to the periodic table to see where these elements are. Magnesium is in period 3 and oxygen is in period 2. So the oxygen atoms are smaller than the magnesium atoms. So when I draw the models, I need to draw a magnesium atom represented with a bigger ball than what I use for oxygen. Okay, I can use slightly bigger balls for oxygen. And what I'm going to do is I'm going to shade the oxygen atoms. Oxygen, though, is a diatomic substance. So the two balls cling together in a chemical bond called a covalent bond because you've got non-metal oxygen atoms clinging together. Now, to know in what ratio the magnesium joins to the oxygen, I need to know the valencies. The valency of magnesium is 2 and that of oxygen is 2. So that tells us that one magnesium atom joins to one oxygen atom. Now, when you look at the diagrams like that, it looks like I've created or I've destroyed one oxygen atom because on the right-hand side of the arrow, you've got one oxygen atom. It's not possible though, so we need to balance the equation. So I need to add another oxygen atom on the right-hand side. But on the right-hand side, you can't have oxygen by itself. You've got to have a magnesium atom clinging to the oxygen atom because magnesium oxide is the product. Now, if I look at that, it looks like I've created an extra magnesium atom. That is not possible. We cannot create atoms or molecules. So what we need here is another magnesium atom. You don't have to connect them because it's the magnesium atom that acts by itself alone. In reality, these atoms are joined in a metallic bond, but I'm afraid some people might say that's a diatomic molecule, which it isn't. Right, so it looks like I have balanced my reaction now because I've got two magnesium atoms on each side, and we've got two oxygen atoms on each side of the arrow. It means that the reaction is balanced. So next, we're going to use symbols. Now, Mg is the symbol for magnesium, and O2 is the symbol for the diatomic oxygen. And MgO is the formula for magnesium oxide. If I look at the diagrams, it's easy to see how to balance the equation. I need two magnesium atoms, and there will be two magnesium oxide molecules forming. So the balancing numbers has a ratio, and those numbers are called coefficients. So we use the coefficient of magnesium, which is 2. The coefficient of oxygen, which is 1, and the coefficient of magnesium oxide, which is 2. And there you have the ratio in which magnesium reacts to oxygen to make magnesium oxide, 2 to 1 to 2. So next step is to determine the mass of the reactants. For this, we go to the mass number of the element on the periodic table. Right. So we have two magnesiums. So the mass of two magnesiums will be 2 times, and the mass of one magnesium is 24. 2 times 24 plus we have oxygen, but there are two atoms of oxygen, so it's 2 times 16 is the mass number of oxygen on the periodic table. So 2 times 24 is 48, and 2 times 16 is 32, so 48 and 32 is 80. Now, in chemistry, when we look at atoms, we don't measure the mass in grams or kilograms. We say atomic mass units, and we just use a U for units. The mass of the product is the following. The product is 2 molecules of magnesium oxide, so it's 2 times magnesium's mass is 24 plus oxygen's mass is 16. So 24 plus 16 is 40, and 40 times 2 is 80. By balancing the equation and then calculating the mass of the reactants to the mass of the products, you will find that the two masses are equal. The total mass of the reactants in this example is 80 units, and the total mass of the products in this example is 80 units as well. So matter is conserved. Hope you find this a useful video.